Okay, so let's now talk about the empirical rule, and this is one of the discussion topic in 3.3. Okay, and so a couple conventions here. First of all, the empirical rule. This idea of using the empirical rule only applies to a normal distribution curve. So it's only applies to a normal distribution. Okay, and so now, as I mentioned in class, or as you have already been aware, a normal distribution is when the distribution curve become a nice bell curve like this, and the curve is nicely symmetric. So the center of the curve is just where the mean value is located at. So now you can see that this horizontal axis right here is indicating where all the actual data value get placed at. And so the actual mean value is right in the center of the curve. And so now, if you're looking at my intention to draw these vertical lines here, is that they're acting as, say, this first vertical line right here, it's the 1 standard deviations above the mean, and this line right here is indicating the score that's precisely 1 standard deviation below the mean. And then for this line right here, it's equivalent to 2 standard deviations above the mean. And this line right here to the left is indicating precisely 2 standard deviations below the mean. And furthermore, we can look at here we have 3 standard deviations below the mean, and here we have 3 standard deviations above the mean. Okay, and so the empirical formula, the empirical rule, is indicating that when you have a normal distribution, then in the interval between 1 standard deviation below up to 1 standard deviation above the mean, this interval that I'm highlighting right now, and indeed let me shade it in, all that area under the curve, under the bell curve, all the area that I'm shading underneath the bell curve, and restricted in between that interval from 1 standard deviation below the mean up to 1 standard deviation above the mean. This interval, according to the empirical rule, there are in that interval there are 68% of data. Okay, in the interval within 1 standard deviations of the mean value. Okay, and so that's the empirical rule. I mean, that's the first rule in the empirical rule. And so now you can see that this interval right here simply just contains 68% of data. Okay, so that interval contains 68% of data. So, and once again, you can see that the interval is centered right at the mean value. And so now, as the second rule in the empirical rule, it's indicating that there are 95% of data, okay, in the interval within 2 standard deviations of the mean. Okay, so this is the idea right here. So now, once again, centering at the mean, if you look into the longer interval, the interval that starts at 2 standard deviations below the mean up to 2 standard deviations above the mean, that interval that I just highlighted, the interval that I'm drawing right here, that interval, you can see that the interval length is actually twice as much as the interval length before. But now, so this interval, according to the empirical rule, it takes, there are a total of 95% according to the empirical rule. And the last interval, and so here once again for the long interval, let me just go ahead and make my shading extend a little further. Okay, so you can see that my shading does seem to make up about 95% of all the shade underneath the curve. And then lastly, there are 99.7% of data, okay, in the interval within 3 standard deviations of the mean value. Okay, so now we're talking about that last interval over here. So now from centering at the mean, once again, centering at the mean, we're looking at the interval that starts from 3 standard deviation below the mean up to 3 standard deviation above the mean. That long interval right here, the long one. And as you can see, my shading extends all the way through. So I have a big, huge shading right here. All that shading. It contains approximately 99.7% of all data. Okay, and so that's the basic idea of the empirical rule. However, this idea does not just simply stop at the 3 basic rules right here, and we can actually develop a lot more application problems out of that. So now, if you look into a little more details about the empirical rules, here's a couple more things that we can directly imply from the empirical rules. So here, once again, let's take a look at a brand new normal distributions. So the mean, once again, is right in the center. Okay, so now instead of looking at the whole interval from 1 standard deviation below the mean up to 1 standard deviation above the mean, if you're looking at just simply the interval right from the mean to 1 standard deviation above the mean, that interval itself right here that I am about to shade right now, so this interval, now if you compare this interval according to the empirical rule, is saying that the interval all the way from 1 standard deviation below the mean up to 1 standard deviation above the mean, all that interval right there would contain 68% of data. But now this interval right here, the shaded area, it seems to be, according to the nature of the curve, which is nicely symmetric, this area that's being shaded right here is precisely half of the area that covers from 1 standard deviation below the mean up to 1 standard deviation above the mean. So that's why this interval length really contains a total of 68%, but we divide it by 2. So that's going to give me a 34%. So this is 34%. Okay, and so similarly, you can see that in this interval length right here, once again, just in between that length, it's another 34% as well, because that's the other half piece. And so you can see the two 34% added together is going to give you that total 68% one more time. Okay, and so now if we consider, okay, so now if you're looking at the interval from 1 standard deviation above the mean to 2 standard deviations above the mean, so in this interval that I'm shading right there, let's try to find out what's the percentage of data being covered in this interval, is contained within this interval. So if you rely on the empirical rule, what we know is that the long interval all the way from -2 standard deviations up to 2 standard deviations above the mean, all that long interval, according to the empirical rule, it contains 95% of data. And now the mean is right in the center. The mean is right in the center as I'm drawing. And so that splits the total area, that splits the 95% into 2 equal halves. And so what I'm seeing here is that all that here I'm shading together with my shaded area here. All that shaded area that I'm drawing right here is all that there is precisely half of 95%. So we have 95 divided by 2, and that's gonna give me a 47.5%. So all that shaded area right there is 47.5%. So the area that we're looking at, that is from that is from 1 standard deviation up to 2 standard deviation above the mean, that area is precisely the large area, 47.5%. Take away, we have learned earlier, this much shaded area is a 34%, just earlier in the video clip. So to find this shaded area right here, to find this area that I'm drawing right there, all you have to do is think about that large shaded area, which is a 47.5%, take away the 34% that I'm covering. And so all that shaded area that remains here is now indeed a 47.5 subtract a 34%. So that remains a 13.5%. That remains in between that. And so similar arguments, you can argue that, and you can without any argument, any formal argument, you can simply quickly see that this area that I'm shading right now is precisely the reflection of the other area on the other hand side. And so that is also another 13.5% in between there. Okay, so on your so you can rely on the similar arguments, or you can just simply take advantage on the symmetric nature of the curve, of the normal distribution curve, and you can argue that this similar area to the left hand side of the mean is also 13.5%. That is the interval from 2 standard deviation below up to 1 standard deviation below the mean.